So today is an overview day, a zoom out day to hopefully see connections, but it doesn't have any work directly tied to what we're going to talk about. Okay, there's three different forms of a quadratic. Most of the time this one is called standard form rather than polynomial form. Standard form, vertex form, and factored form. So we're going to talk about each one of them, talk about how they connect, and you'll still have 20-25 minutes left to finish the factoring for today. I want to start by talking about vertex form because I think it's the easiest to deal with. The one out there is not really anything other than first to talk about. First, why do you think it's called vertex form? It tells you where the vertex is. That's why we like it. It's easy to find the vertex. The minus h sometimes throws people off, but we use the minus h, remember, because x is the backwards one. So x minus h means we would go right h and up k. This is the form that all of the ones on yesterday's worksheet were. So they were easy to graph because it was easy to find the vertex and then do the 1, 1, 2, 4 stuff, and away you went. So we like vertex form. It's easy to graph. What does the A do for it? What does the A do to the graph? So stretch or compress. Right, stretch if it's bigger than 1. Compress if it's less than 1. What else might A do? Could flip it. If it's negative, it flips it. If A is less than 0. If A is negative, that would flip it over. Again, we're kind of just summarizing things you know, but we're taking a step back to try to see all of it at once. I suppose this is debatable, but I don't know. I would debate you if you disagreed. It's the easiest form for graphing, because it's super easy to find the vertex. And then the A is right there if you need a stretch factor on your 1, 1, 2, 4. And so we like that format for graphing. That was Monday's worksheet. Make some connections. Okay, I don't know that we need to say much else about vertex form. Let's talk about factored form. Number 2. Factored form, it's obviously factored. That's why we call it factored form. Let's take one of the connections. I'm literally going to zoom out here. To get from standard form, excuse me. To get from standard form to factored form, don't overthink this. What do you have to do to get from a quadratic that looks like that to a quadratic that looks like that? You factor it. So we know how to get from standard form to factored form. You factor it. Do you know what you would do to go the other direction from factored form into standard form? Unfactored. What's another name for unfactor? You're right. FOIL, or distribute. Factored form is nice for solving, so I'm going to say that it's the easiest form for solving. We haven't done it this year. I think you did it in Algebra 1. Do you know what you do with the factors if you want to solve or if you want to find where the zeros are? How would you find what point to use? It's easier than all of that. We would just set each one equal to 0. Set the factors equal to 0. factors equal to 0. And then you have 2 easy equations rather than 1 hard equation. And almost always in math, we'd much rather solve 2 easy equations than 1 hard equation, especially when they're that easy. And you just add R1 to the other side and add R2 to the other side, and there's your 2 answers. And those 2 answers have a bunch of different names. Solutions, roots, zeros, and x-intercepts. Those are all the same thing. Sometimes students get confused when we start doing those. They're like, oh, I don't know how to find the roots. I can find the solutions, but how do I find the roots? Hold on. They're all the same thing. So we'll ask it a bunch of different ways, but it's really the same thing. In fact, those are all x values that make y equals 0. X values that make y equals 0. I mean, that's pretty much the definition of an x-intercept. Like, what values of x make y equal 0? Because they make y equal 0, we call them zeros. We call them solutions. We call them roots. So all those are kind of the same thing. All right. And because we can do a lot with factored form, that's why we spend so much time factoring, taking them from standard form into factored form. That was Friday's worksheet, and it'll be today's worksheet as well. All right, let's talk about standard form. So standard form isn't as helpful. Like, I don't get to say it's the easiest for blank because it's not really the easiest form to deal with. I guess it's maybe the easiest to look at because there's no parentheses, and that's why we call it standard. But it doesn't help us a whole lot. So there's a few things we can get, but not much. The A is the same A in all of them, so that still tells us if it's stretched or compressed, or if it's flipped. So even though it doesn't tell us much, we'll know if it's steep or squished or flipped. C. Let's see. If I plugged in 0, I would just get C left, right? If I plugged in 0, the other stuff will go away. So if x equals 0, then 0C is a point, which makes it the y-intercept. So it's easy to find the y-intercept, but only the y-intercept doesn't usually do you much good when graphing. So okay, now we'll just say later, so I'll say a few more things even though we're not really going to talk about them, other than to say we'll get to them later. One is how to find the vertex from that form. It's not as easy as vertex form. You can't just read off the numbers. I think you did this in Algebra 1. The formula to find the vertex, or the x-coordinate of the vertex, is negative b over 2a. We'll mess with that tomorrow. And then much later, I don't know when, I mean it's in this unit, but it's not tomorrow, solve with the quadratic formula. Hopefully the quadratic formula is still rattling around in your brain somewhere, but if not, we'll talk about it sometime. Oh, not even until after the break, I think. So it'll be a while. X equals negative b plus or minus the square root v squared minus 4ac. There you go. So you've heard the song. You know the... Riley, you hadn't heard the song? Okay. Oh, I'll sing it a bunch more times when we get there. So Okay, so that's about it for standard form. By the way, on Thursday we'll graph from standard form. So we'll use that vertex formula, we'll use some of our stretch and compress stuff, but that's another thing that's like, not there yet. So again, we're trying to just see that there's different ways to write a parabola, write a quadratic, and some ways are helpful for some things, but not helpful for others, and we want to be comfortable with all of them. So today really is just step back, appreciate, understand the connections between them. Dylan?
Today's assignment due Friday?
It'll be due Friday. Today's assignment will be due Friday. One more thing I want to make a connection with, and that is how to get from standard form to vertex form. I would say, or I think you could figure out how to get from vertex form to standard form. What would you do if it looked like this and you wanted it to look like that? Dylan, you going to answer that question? No. What would you do if it looked like this and you wanted it to look like that? Taylor?
Maybe you'd do this, you'd square x minus h and then multiply by a.
Pretty much. FOIL, multiply by a, add the k. Like, basically simplify that thing. Or expand it. Yeah, you would take what's there, blow it all out, combine like terms, and then you'd be back in standard form. We don't usually do that because why would you do that, right? Vertex form is nice. Why would you be doing that to get into standard form? But you could. What's harder, although more helpful, is to go the other way. Right? We like vertex form because it's easy to read off the vertex. So if there was a way to get from standard form to vertex form, that would be nice. That would be helpful. And there is, it's another one of those later topics, complete the square. Did y'all do complete the square in Algebra 1? Okay. You may not remember it because it's kind of a longer process. You take half of b, square it, and add it to both sides. We'll do it later. We don't have to worry about it right now. Again, today's notes are just about seeing that there's different forms. You can navigate between them. Some of the forms are helpful in some places and not so helpful in others. We also don't really have a connection between vertex form and factored form, because if you wanted to get from one to the other, you'd pretty much go through standard form to get there. You can't really just jump straight there. You would pass through standard form on your way either direction. Okay, so it's kind of a nice day. It's like, a lot of notes, but no work associated with it. Today's assignment, so we'll go backwards a page. It's the worksheet from yesterday, except today's assignment is those 10 factoring problems. That will be part of what's due Friday. And so you've got like 30 minutes left to work on those factoring or finish up the graphs if you haven't finished them. Some of these are tricky. We start to get a little trickier. But you've got all the time you need. Certainly welcome to work together. I will help you. But they start to get a little harder today. CJ?
If you look at